Lenses. Lenses are used to form images, and they are also used to bend light. So we're going to study images that are formed on. So the structure of a convex lens is shown in the diagram. Right in the center of the lens, we do have the optical center. At the side of the optical center, we do have the principal focus, which is the focal point. So rays are going to be refracted. So we have those parallel rays that get refracted when they get into the center of the lens. They get refracted through the principal focus, which is the focal point. Now, the focal length is the distance between the center of the lens, which is the optical center, and the principal focus. You can think of a lens as small pieces of prisms that tend to refract light. So they form what is called like parallel-sided plot. Now, to find the principal focus of a lens, take the lens as shown in the diagram, move the lens towards the screen until you can see an image through the window. Okay, so you've got to do this experiment with the window open so that an image of what is outside is shown on the screen. Now, in this animation, we are going to go through how images are formed when the object is placed at different points. For example, the object is placed beyond 2F first, then at 2F, between F and 2F, at F, and then between F and the optical center. So we're going to start off with the object beyond 2F. As you can see, the image that is formed smaller than the object, it is at a distance of between F and 2F. Okay, so that's how you describe the image that is formed on convex lens. 1, it is inverted. 2, it is smaller than the object. 3, it is at a distance between F and 2F. Now let's move on to talk about the image that is formed by an object placed at 2F. As you can see, the image is right at 2F. It is the same size as the object. It is inverted. It is real. It is real because light rays actually reach the image. Now, there's one thing that I want to stress here. A ray that is drawn parallel to the principal axis, that is from the tip of the object, and gets refracted through the center of the lens, passes through the principal focus. The first ray that you please don't forget to put the arrows. And then there's a ray that passes through the center of the lens, the optical center, unrefracted. So when these two rays meet, that's where you've got the head of the image. Image is going to be inverted. You also have another ray that comes from the object, then goes through F prime, and then goes to the lens, gets refracted, and then it moves parallel to the principal axis. So you can draw 2 or 3 rays that I've just described. Now we're going to continue. When the object is placed between 2F and F, the image is going to be real, inverted, slightly larger than the object, and the image occurs beyond 2F, as you can see there. Then if the object is placed at F, as you can see, the rays are parallel. There is no convergence on the other side. So we say the image is at infinity. Now, when the ray is placed between F and C, there is no convergence on this other side of the lens. Instead, convergence will be on the same side where the object is. The image is going to be upright, larger than the object. It is virtual. Why? Because there are no light rays that reach image. So this is an application of the lens as a magnifying glass. Okay, so we've covered all the possible outcomes when the object is placed at various points on one side of the lens. If you have any questions, comments, please write them in the comment section below. Don't forget to like, share, and subscribe to the Physics Tips for Cambridge Students YouTube channel.